Welcome to Highline BI 348 class video number 56. Hey, if you want to download this workbook, BI 348 Chapter 5, and follow along, click on the link below the video. Hey, we're talking Chapter 5. We're talking about forecasting. The last couple of videos, we've seen some different methods for forecasting. But if we plot a time series, time variable, and some values, and we see what looks like a trend, and we believe that this trend will extend into the future, we can use regression to make a forecast. Now, our last chapter, Chapter 4, when we studied regression, we said make sure when you make a prediction to keep within the min and max of the x values. But this is different. We have a time series, and our assumption is that this trend will continue into the future. Now, here's our data set. We have months and sales. Now, we have learned various methods to calculate slope and intercept to create our linear regression equation. But I think this time we will use data and data analysis feature. And then regression. Click OK. Now, our y input, there's going to be our sales. Our x, that's our time variable. I call it x. The textbook calls it t. That's fine. It's an independent variable. We definitely have labels at the top. Confidence interval, we can change it. We're not going to do any hypothesis testing like we did last chapter, but we'll spit out the confidence interval anyway. I'm going to say residuals, residual plots. We're not going to use those either, but you can look at them if you want. And our output range, we'll say something like M1. Click OK. And so there are our regression statistics. If we were hypothesis testing, we'd see our residual plot, which looks pretty good. We have our f-test statistic, our p-value. But all we're interested in is this, the slope and the intercept. So what this means, and if we look over here, our variable is month with increments of 1. So they have equal time periods. For every 1 month, units increase by about 5. Now, we can come over and make our forecast, period 25, 26, 27, and 28. Just extending beyond the bottom of our data set. Hey, equals, and our slope, that's going to be time t, and I'm going to lock it with the F4 key, times our x variable. Remember, that slope means about 5 units for every month. We started at 1, went to 24, now we're at 25. You can think of the slope here as an average increase per month. And that'll be a relative cell reference, plus, and then we'll go get our y-intercept. And I'm going to lock it with the F4 key. Control, Enter, and copy it down. So that's pretty convenient. F2, we're checking it. It looks good. As long as our assumption that this trend will continue, then that will be a good forecast. Now, there's a great function in Excel that does exactly this. It forecasts using linear regression. And guess what? They named it smartly. Equals forecast. It needs to know the particular x, comma, the known y's. We highlight all of them, and we're going to have to hit the F4 key, comma, and the known x's. And I'm going to have to lock it with the F4 key. And here's how cool the forecast function is. Because I put x's and y's in and a particular x, forecast will actually calculate the slope and the intercept for us and use that x in the estimated regression equation and calculate the exact same answer. So I can copy it down. Either way you go. That's pretty cool to have a forecast function. Now, I want to calculate mean square error for forecasting. So I'm going to come over here. Remember, we need the actual values, your actual forecast, and we're going to use regression, and then the forecast error, et cetera, et cetera. So we're going to say equals, and we're using the forecast function. There's time period 1. That's our x, comma. There's the y's, F4, comma, and the known x's. F4, close parentheses, Control, Enter. I'm going to calculate forecast error right off the bat equals the particular value minus the forecast. Now again, this says forecast error, but we've seen error like this throughout our whole class. We've seen deviation, which is a particular value minus x bar. We've seen residual, which is the x minus the value predicted by our equation, which is exactly what we're doing here. Last chapter, we called this residual. Here, we're calling it forecast error. So I'm going to Control-Enter and then highlight both of them and double-click and send both of them down. I can go and check and see. It looks like it's working. Now, we're going to calculate mean square error. I'm not going to do the extra column with the squared and then add it up. I'm just going to come over here. And, of course, there's a function, just like we saw in Chapter 4, sum of squares. And what it does is it will first, we're taking our error, just like last chapter we took our residual. Take all of those, it will square it, and then sum it. Now, that's not quite enough. I'm going to Control-Enter because I forgot something. Last chapter, that would be called sum of the square of residuals or errors. But check this out. Last chapter, whereas we took that amount and divided by degrees of freedom in forecasting, we're going to take it and divide by the number of forecasts. That's our n minus k we've been talking about in the last couple of videos. So I'm going to count all of our forecasts, which happens to be exactly the same as our number of observations, right? Now I can take F2 and divide it by our 24, and that will give us our mean square error for forecasting. Now we want to be careful because mean square error for forecasting is going to be calculated slightly differently than our last chapter, Chapter 4. And the only difference is the denominator. Here, we're actually in the denominator using the count of all of the forecasts. Now remember, we saw exponential smoothing and moving averages, and we had different numbers of forecasts that we had in those examples compared to the actual sample size or n count of all the actual values. So when we get to mean square error for forecasting, we're going to divide by the total count of all of our forecasts. Now I want to show you a different way to calculate this. If you do this output, you have the two pieces you need. There's the total observations. And remember, sum of the square of residual is the same as SSE, or sum of the squares of error, and there it is. If we come over here from this output, we can take sum of the squares of the error divided by our total count. And there it is. We get that. Now, I want to remind you we had a slightly different calculation. And guess what? Back in Chapter 4 and 5, all they call both of these numbers that come out with different answers, they call them mean square error. They don't differentiate. So here I said mean square error for forecasting and mean square error for regression. The difference is we're going to take our sum of the squares of error, and we divide by our degrees of freedom. We take into account that we had some parameters that we estimated. So there would be, for regression, the mean square error. And you can see that's actually calculated in the output, mean square of residual or errors. But this is what we're going to use, mean square error for forecasting. Now, here we had simple linear regression, a single variable, and it was a quantitative variable, a number. Now, we're going to come look at our sheet, regression, seasonality, no trend. Here's our data set, year, quarter, and sales. And here's the line chart for our time series. And it looks like we definitely have a seasonal or periodic pattern. Quarter 4, quarter 4. Quarter 4 always seems to be the lowest. And so we want to see how to use linear regression to create a forecast. Now, what we're going to have to do is transform this data set. If you remember last chapter, Chapter 4, when we had a categorical variable, we had to break a particular column apart into multiple columns and then use zeros and ones to represent whether it was that particular variable or not. Now, I'm going to copy just the sales, Control-C, 1, 2, 3, and I'm going to put it right here, Control-V, so in K1. Now, the way this works, and we saw this last chapter with only 2 categories. Here we have 4. What this means is we're going to have to add 1, 2, 3 extra columns to our data set. Why 3? Because if you have whatever number of categorical variables, you have one less column than there are variables. So since we have 4 categories, quarter 1, quarter 2, quarter 3, quarter 4, that's 4 categorical variables. 4 minus 1 is 3 columns. So we're going to call this quarter 1, Control Enter, and fill handle it over. I'm going to Control B. And you might be asking, well, wait a second, what happened to 4? Well, here's what's going to happen. When we run linear regression, we're going to get 1, 2, 3 slopes. Now, if you look at this data set right here, if we were predicting based on quarter 1, we would not want the quarter 2, quarter 3, or quarter 4 slope. However, when we got down to quarter 2, we wouldn't want quarter 1, quarter 3 slope, and we wouldn't want quarter 4, which will be part of the y-intercept. We'd want just quarter 2, and so on. Quarter 3, down here, we'd only want the slope from quarter 3. So here's how it works. Once you have 4 categorical variables, you list 1, 2, 3 of them. When we get to a record in our data set or a forecast for quarter 1, we'll multiply our x value 1 times the slope for quarter 1, and then 0 times 2 and 0 times 3. When we get to quarter 2, 0 times the slope for quarter 1, but 1 times the slope for quarter 2. 0 for quarter 3. For quarter 3, only a 1 for quarter 3. But when we get to quarter 4, we have 0, 0, 0, because the slope for quarter 4 will already be incorporated into the y-intercept. But what does that mean? How are we going to add these extra 3 columns? Well, you have to create a table like this, quarter 1, quarter 2, and describe the logic of how you're going to apply the slopes in your equation. Once you have that, I don't want to do it manually over here, so we're going to apply some of our Excel skills. We definitely know how to use VLOOKUP. We definitely know how to use the match function. And we definitely know how to use mixed cell references. And we're going to put a formula here. And I actually put this new data set right next to the old data set so I can look up each one of the proper quarters. So I'm going to use equals VLOOKUP. And I'm looking up this quarter here. Now I'm going to have VLOOKUP find the quarter here, and then look up the appropriate 1 or 0 for each quarter. Now think about this. That cell reference, when I copy over to the side, I need to be locked on that quarter. But when I copy it down, it needs to move to the quarter 2 and then quarter 3. So that means I need to hit the F4 key 1, 2, 3 times. C is locked, so when I go this way, it's locked on C4. But the 4 doesn't have a dollar sign, so when I move down, it goes to C5, C6, etc. Comma. The table, first column has the thing we're going to match. Subsequent columns are the things we're going to look up. I need to lock it with the F4 key, comma. The column index number, well, for quarter 1, I need the second column in the VLOOKUP table. That has the thing I want to get and bring back. Quarter 2 has 1, 2. It's in the third column. And quarter 3, the thing I want to go get from this table and bring back is in the 1, 2, 3, 4 column. I do not want to type this in and edit it, especially when you get categorical variables that are many columns long. Actually, some of the homework problems in the textbook have 6, 7, 8 columns like this. So I'm actually going to look up the quarter within that range, those field names, with the match function. Match function will tell me, are you the first item in this range, second, third, or fourth? Notice quarter 1 is in the second relative position, which will be perfect for column number for VLOOKUP. Match is going to sit right in that VLOOKUP column index number. Now watch, when I hit Tab, the screen tip changes. Now the lookup value, I want the quarter. When I copy this one down, I need it locked. But when I move to the side, I want it to move relatively. So I hit the F4 key once and twice, comma, lookup array. That's this range of field names at the top. And I'm going to lock it F4, comma, The lookup type for match is exact because I'm doing text 0. And watch this. When I close parentheses, that screen tip will disappear. Close parentheses. It jumps back to VLOOKUP. Column index has match. That's just delivering the relative position, which will tell VLOOKUP which column to go and get the number from. Comma, and the final argument in VLOOKUP is exact match. I'm putting a 0. Close parentheses, Control Enter. Whoa, an NA, that means not available. That means either that or one of these two lookups are not correct, or actually one of these over here. So I'm going to hit F2. And sure enough, look at that. QRT, QTR, I made a typing error. I'm going to edit this and change the middle part to TR. Control Enter. Copy this over. Spelling is my downfall. Now I'm going to copy the formula over, double click and send it down, go to the last cell and hit F2 to check. Sure enough, the VLOOKUP's in the correct place. The range for both match and VLOOKUP are in the right place. The match lookup value is correct. That is amazing. Now I'm going to add some formatting. Now I have my proper new table with 1, 2, 3 x variables to pick up a seasonal trend in linear regression and my y. I'm going to use the built-in feature Data Analysis. Actually, this is an add-in. You have to go to Tools, Add-ins, and add in Data Analysis. Click OK. The input range, I better make sure, and I definitely want to include the label at the top, particularly if you're doing multiple regression, because we're going to need to pick out the right slope. So these field names at the top are very important. So when I go to X input, I'm going to delete that, highlight the field names, and then all of the records for those X variables. Labels, confidence interval, residuals, we're not going to use any of that. That's for hypothesis testing, but I definitely want to change this. Scroll over and put it in like something like T1. Click OK. And now we can see over here our intercept, quarter 1, quarter 2, quarter 3, slope values. Now, in this example, if we looked over here, quarter 4 is always the smallest. So that means this y-intercept includes that value in it. We don't know exactly what it is. But that's why, since quarter 4 is smallest, quarter 1 will add some, quarter 2 will add some more. On average, that's the biggest quarter. And then quarter 3 will add some. Actually, in our next example, we'll have a reversed example. Quarter 4, I think, is the smallest, so some of these slopes will come out negative. We can build our formula for estimating. Now, what in the world are we going to do? If we have slopes, what is the actual x value? They're up here. Equal sign, I'm going to go down and get my slope for quarter 1, and I'm going to hit the F4 key, times my x. Now, you could build a separate formula for each one of these, but I'm not. I'm just going to build it as if there is an x value and a slope every time, plus the slope for quarter 2, and I'm going to hit the F4 key, times, and there's my x value. Notice it's a relative cell reference, so when I copy down, it's going to be in the same order as quarter 1, quarter 2, 3, 4 here. Plus, by the way, I could have put these x variables right next to this data set if I wanted. The next slope is for quarter 3, and I'm going to hit F4 times, and there's our x value, plus our y-intercept, and I'm going to hit F4. Now I can Control Enter, and there, if I copy this down, are our estimates for quarter 1, 2, 3, and 4. And we could see that the estimate for quarter 4 is the smallest because in our original source time series, that was the pattern that was displayed. Now, as we discussed earlier in this video and past videos, we definitely want to calculate mean square error. And I'm going to put for regression, and I'm actually going to move this over here, format it, and I'm going to calculate it from my output. Remember, sum of the squares of residuals is the same as sum of the squares of error, and I'm going to divide it by, not degrees of freedom, observations. And there is the mean square error. All right, so here In the second example in this video, we had just to season. Now we want to go over to the next sheet tab. All right, we're going to click on the sheet, Regression Seasonality with Trend 3. Here's our data set, different data set, and look at this. It definitely looks like quarter two, quarter two, quarter two. That's the low point, and it looks like quarter four, four, four. Four is the high point, but there's also an upward trend. So when we see that, we can use linear regression. Now, in our last example, we saw just season. So that meant we had to break quarter apart into 1, 2, 3. And we built our little lookup table. The patterns of zeros and ones indicate when we use the slope and when we don't use the slope. And we created our formula. But look at this. We also have now a fourth variable. This is time. Straight from over here, this t variable here represents quarter. And so now we're going to include that. This new variable here will also get a slope, and it means the slope of that will indicate for each quarter whatever, it'll be an increase, right? For each quarter, there'll be an increase. 1, 2, 3, 4 x variables, 4 slopes, and a y-intercept. All right, we're going to use data. Over to data analysis, regression. And now we want to make sure we put our y, so it's highlighted. Here's the y, and I want to make sure and have the actual label at the top and all the values. And then the x's, 1, 2, 3, 4 labels and all of the records for each one of those variables. Labels, confidence, residuals, that's all OK. We have T1, so I'm going to click OK. And down here, look at that. Now we have quarter 1, quarter 2, quarter 3. The slopes are negative, right? Because quarter 4 is the highest. So anytime we get a 1 from here, it'll be subtracting because the amount for quarter 4 will be in the y-intercept. And we also have 1, 2, 3, and a fourth independent variable and slope. That means for each quarter over here, since our data was in thousands, this means like a $1,400 increase. All right, let's build our estimated regression formula. Equals, and let's try quarter 1 slope, and I'm going to hit the F4 to lock it, times, and there's my x for quarter 1, plus, now I get my slope for quarter 2, and I'm going to hit F4 to lock it, times the x for slope 2, plus slope number 3, F4 times x plus, and now we're going to get slope number 4, and I'm going to hit F4. That's for the time variable, times, and there it is, 17, 18, 19, 20. Those are the next 4 quarters. Notice our last quarter over here was 16. So 17, boom, that will be our x or t. And then we have to add our y-intercept. F4, Control-Enter, and copy it down. You got to be kidding. We have a way to forecast using multiple linear regression and a categorical variable when we see seasonality and a trend. Now, here we used all of the x's. You actually could use an individual formula for each one because you only need one of these slopes for each one, 1, 2, 3, or 4. Here's an alternative way. Now watch this. I'm going to click on the slope for quarter 1, and I'm not going to even multiply because the slope times 1 is the slope. And I'm noticing quarter 1, 2, 3, 1, 2, 3. So I can just copy this down. It will automatically get the right slope for each one of those quarters. But I have to add the slope for our time variable, F4 times the actual relative cell reference. That's the time period. And now I simply have to add the y-intercept, F4, Control-Enter, and I can copy it down. Then I have to create a separate one here, equals simply slope, F4 times 20 plus our y-intercept. And actually, I didn't need to even lock that one, and boom. All right, in this video, we saw how to use linear regression to take a seasonal and trend pattern for a time series and create an estimated regression formula for forecasting. Over on the sheet reg seasonality no trend, we saw how to use linear regression to forecast when there's only seasonality. And then back on the first sheet over here, we had just a trend, and we used linear regression, and we used the cool forecast function. All right, that's it for Chapter 5. We'll see you next chapter and next video.